who are you?
Who am I? I'm Chris Muench. I'm one of the MVPs for the Embedded and Devices group, and I'm working at Siemens in my daytime job as a technology advisor, technology consultant, however you want to say that. And in my spare time, I'm developing games, working on Pocket PC devices like the Windows Mobile stuff, and a lot with 3D in the last couple.
So what's your background on Windows Mobile graphics and Direct 3D?
Actually, I started very, very early with Direct 3D and Windows Mobile. In fact, I was one of the alpha sites for the NetCF team on the managed part of Windows 3D Mobile. And I wrote a game for Pocket PC, Windows Mobile 5, solely on compact framework with Direct 3D Mobile. And it's selling on Handango. And if you want to have a sneak peek at it, I will very happy to show you. It's looking like this.
Let's zoom in so we can see the game. Roughly, what is the size of the binary for that?
The size of the what?
The binary?
The binary? Oh,
Mm-hmm.
it's about 300K, and most of it is actually graphics and textures, everything that the game needs beside the code. The code itself is maybe a couple kilobytes, maybe 50 kilobytes or something. But with every game, most of the stuff these days is in the graphics and the sounds and everything that makes the content of the game. So writing code in Compact Framework and .NET and managed Direct 3D is reducing the code size dramatically. So if you have the luck of having Compact Framework in ROM, you have most of the stuff already on the device that you need to run these things. And then 50 kilobytes for the code, and the rest is a content file that is even possible to put next to it or download from the internet. This game allows to customize those tiles that you can see here.
So is Compact Framework programming fast enough to write kind of good 3D games? I guess many people are used to writing native code applications, C,
Right.
C++, on their Windows Mobile devices, and moving to the Compact Framework. One issue is potentially the size of the framework on the device, but if it's in ROM, that's no longer an issue.
Right.
And one, of course, is the performance of managed code on a device. Would you say it's good enough?
It is good enough for casual games, for anything that is not really CPU intensive. So if you want to build a first-person shooter on that, you might want to fall back to native code. But the difference between native and managed is very little compared to what you really get out of that Compact Framework solution. And everything I'm doing, and I'm also moving from casual games over to production games, is just fine with managed code. I have not seen any limitation. The device itself is running between 300 and 600 megahertz, and compared to a desktop solution, this is like about a fifth of the power of a desktop. And with the screen getting larger, the power needed to run full screen games at 640 by 480 is on the edge. So we need to hope for the next generation of CPUs on that to get really like first-person shooters on this.
So previous Windows mobile devices ran something called GAPI, or the Games API, and now I guess we're moving to this kind of Direct 3D kind of interface.
Right.
What's the difference between GAPI and Direct 3D, and how do I make a decision about which I should be using?
Yeah, GAPI is the direct access to the screen hardware, basically to the memory of the screen hardware. So you can write your bits directly into the screen buffer, which is for a lot of games already very sufficient. But if you want to do 3D stuff like matrix calculations, rotations, and perspective, shading, lights and stuff, you have to do an awful lot of calculations, and you basically rewrite Direct 3D if you use GAPI. The only thing you can do with GAPI is poke into the memory of the graphic card, but it gives you nothing extra to help you with 3D calculation. So you can do that if you have really a lot of time on your hands and you want to rewrite something Microsoft Word has already done very nicely. Why knock yourself off?
How compatible is Direct 3D on Windows mobile devices when compared with Direct 3D on the desktop?
It's very good compatible at the current stage. So the 1.x managed framework on the desktop is nearly 100% identical to the device side. So if you start with the device side and then move over to the desktop, you don't have to do anything. It just runs there.
Right.
If you go the other way around, there are a couple things you have to not do.
Okay, so the game you've just showed us on the Pocket PC
runs 1-to-1 also on the desktop.
Because it's MSIL, I can just take the binary, drop it up on the desktop, and run it.
Well, yes and no. The code, the source code, is compatible. The binary is not. So there's an assembly on the desktop that has a different signature and everything than on the device.
Okay.
So you cannot just run the binary on the desktop. That does not work.
Okay, so
but
it's just a rebuild.
You just recompile it, and that works.
Okay.
And that's great. Now with version 2 of the managed DirectX that's coming actually very soon, things will change. So we'll see how that works out. That has to do with .NET Framework 2.0 that has been released with Visual Studio 2005, and Managed DirectX 2.0 is complying to that. The good thing about that is it will run on 64-bit natively. It will run in the 2.0 framework on the desktop natively, so you don't have to go and funk back to 1.1 or something like that, which is currently the case with if you run a 2.0 up and the 1.0 Managed DirectX. And at some point in time, mobile Managed DirectX has to comply to that too.
Okay.
So there will be a little gap when 2.0 on the desktop comes out, and until the 2.0 Managed DirectX comes out for the device.
So does that mean that developers should hang off and wait?
They should hang off and wait a little bit, except they only try to develop for the desktop.
Okay.
If they do not plan on going for the device, then they could start looking at the 2.0 framework. But it's in very early stages right now. It's if you download the December bits of the DirectX SDK, there's a beta version of the 2.0 framework, of the 2.0 DirectX managed framework inside.
Okay.
And I recommend right now, if you want to play with it, fine, but don't do anything productive with it.
So for Windows Mobile developers now, use Visual Studio 2005?
2005 with the 1.0 framework. The device side there's only one thing there, so you cannot do anything wrong.
Okay. And when you say 1.0 framework, you don't mean 1.0 of the compact framework?
No, I don't mean 1.0 of the compact framework. So, okay, we have the 1.0 compact framework. That does not have any direct 3D stuff. Then we have the 2.0 framework of the compact framework, the Microsoft.NET Compact Framework 2.0, which includes Managed DirectX.
Okay.
1.0.
Okay, right. Got it.
So, yeah, the versioning is always troublesome with Microsoft, but, well. Then, on the desktop, there's 2.0 framework, and 1.0 .NET Managed DirectX. It's basically the same scenario, but they also added now the 2.0 DirectX Managed Framework, which
so can I program against this this framework from both native and managed code on Windows mobile devices?
Well, you can. DirectX Mobile is a COM-DLL basically, so it is native, and then there's a DirectX a managed assembly on top of that calls into the COM-DLL. Okay. And that's also the reason why it's not available for 1.0 framework, because there's no COM interrupt in 1.0 framework. But in 2.0, everything is there. And if you don't like managed code, you can just go against the native COM-DLLs. Right. And it's, again, very similar to the desktop. Okay. The interfaces are the same, the naming is the same.
So your recommendation would be to go managed, though?
I'm not doing any native code for a long time now, so it really depends on if you need this extra 5% speed at the end or not. And I have not found a reason yet to go back to native. It's really not that much of a difference. The most of the stuff is going down to the hardware anyway, so the COM-DLL is not doing anything else than taking the call from the top and making it for the hardware. So as a pass-through, basically, and on the desktop it's even worse, or even better if you want to say, because everything runs on the graphic card really. So the COM-DLL and the native the managed wrapper basically it's just handing your code down to the graphic card. So there's nearly no overhead that these two are generating except of passing pointers down to the hardware.
Okay.
So
well, can we take a look at how to write some code?
Alrighty.
Sure.
Let's do that. So, okay, let's do a little Direct 3D application from scratch. I have Visual Studio 2005 here, and I have the emulator open. We start writing a little application. Alright. So first, as with all good things, we try to open a new project with this mouse. Call it 3D1 or whatever you like to do. So now we get this nice little framework application from the proprietary SDK, which has to be installed beforehand, of course. But you don't need anything else. Visual Studio 2005 and the Windows Mobile 5 SDKs, nothing else. Then, since we do a 3D app, we don't actually need forms. We just use them as a container for the 3D stuff. So what I'm doing first is delete the designer code, because we really don't need that. Then we go into the main loop and add the 3D main loop to it. And I prepared a little snippet that makes it easier for me to type. And we call it main loop. So what we're doing is we initialize the graphics and then we run the form, which is very much the same as the original code, except this initialize graphics, which creates a device and all these things that we need for 3D. So then in the form itself, we need to add, let's do that first, the actual Direct 3D assembly, Windows Mobile DirectX. This is the only assembly we need for all
So
this
you've
stuff.
just added a reference to that?
I added a reference for that, and this assembly will be installed with the Windows Mobile 5 SDK for Pocket PC. And then we also need some new extensions here, or assemblies, the DirectX extension and the Direct 3D extension. And also the interop assembly for, because I mentioned the Direct 3D DLLs are all COM DLLs, and you need to be able to poke through from manage code. And the next thing is we add another snippet that I prepared here, and I will go through the code in a couple seconds. That initializes the graphics. So everything in 3D or in DirectX is called a device. If it's a sound device or a 3D device or a DirectX device, everything is called a device. And this little thing, a vertex buffer, is basically a byte array of points in 3D space. So we have a form, we give it a text title, and we don't want a minimize box, so very, very basic initialization. This is basically what the designer would have done, but we don't need all this stuff that the designer actually is doing. Then we initialize the graphics, also very easy. Presentation parameters describes the device, how it will be presented, as it says, presenting parameters. We want to have it windowed, so it will not be full screen. And we will have the swap effect discard, which basically destroys the second device, the back buffer once it's used.
Why don't you want this to be full screen? Why is this windowed?
Well, we can switch it to full screen if you want to, but right now to close it, I need the close button. And
right.
If I don't do that, well, I have to put in key code to escape, and I'm just lazy right now.
Okay.
So you can do full screen here just fine, but you have to write your own HUD. But what I'm actually recommending in casual games is that you keep the menu bar and you keep like the icon bar on the bottom, that you can control the game with that.
Right.
If you have a first-person shooter or something, well, the trade-off is always if you remove the Windows UI, you have to build your own.
Yeah.
So if you build your own HUD, heads-up display, you can get full screen.
Sure.
And if you don't want to do that, like me, I'm a lazy guy. I just use whatever Pocket PC gives me. Then you rather go with Windows.
Okay.
Doesn't make a difference in speed, by the way, on the Pocket PC. Because
Right.
there's no hardware acceleration difference between Windows and full screen. Okay, and then we create the device. It's also very easy. On the desktop, you have a lot more parameters here that you can set, that you want to set. But on the device, this is basically all you need to do. Very, very primitive. Then you create the device, and once you have the create device, you call one of those events that gets that initializes everything in the device, like the vertex buffer and anything else that we'll add later. So when the device gets destroyed for some reason, for example, Pocket PC puts the 3D device in the background, or it suspends and stuff like that, this event will be called again and reinitializes all your 3D stuff, and that's why you go through the event handler.
Right.
And you see on create vertex buffer is another handler that we add. If the vertex buffer is created, we want to have for a triangle all the vertices set up. So you see we add 3 vertices to that vertex buffer and write it into that array. Vertices are basically 3D coordinates of a triangle. So you see 3 coordinates, the x, the y, and the z coordinate. And in this case, it's a transform colored vertice, so it has also a color. Each vertice has a certain color, aqua, brown, and light pink. And you will see when the rectangle will be rendered that Dark 3D already creates the radiance between them, and you have a nicely colored triangle. There are a couple of different vertice types, position colored, normal. So depending on how the vertices are described, they will be represented in 3D space. And there are very good books and tutorials out there that describe that. But for a primitive tutorial, we just stick with that now. Okay, so if we would start that application right now, it would create the device, show widescreen, and create the buffers, but doesn't display anything because we haven't done anything for the rendering yet. So the next step is we add the render part. And we have another snippet for that called oh, clever. So the setup matrices is a matrices are the most important thing in 3D space. Since we have 3D coordinates and we want to rotate and manipulate them, transit them in space, want to do something with them, we have to describe that in matrices. And Direct 3D takes these matrices and then projects it into 2D space. So it's very easy to manipulate the matrices, which by the way works on all devices even if there's no Direct 3D on it, because it's a pure managed assembly. So if you want to build against Garpion devices that does not have 3D hardware acceleration, you can still use all the matrix functionality on that device. Very cool feature of the managed stuff.
Good.
And we of course have to set up this matrix. We have to calculate an angle. In this case we transform a rotation around the y-axis, so the triangle will spin around its y-axis. Then we set where the camera is, and we set basically how far the camera is away from the triangle. So by playing with all these parameters, you can already create movement around it. You can shift the triangle, you can move it back and forth, and do fun stuff with it. And you see, it's not much that you have to do. You have to set the world coordinates, the transformation matrix of that triangle. You set the camera and you set the perspective. So if you have a pocket PC, it's 3x4. If you rotate it, it's 4x3. If it's a 16x9 pocket PC, you have different perspectives. And Direct 3D needs to know that to calculate all the 3D rotations and everything correctly. And this is what you do with the perspective for LH, which means left-handed coordinate system.
So what's going to call into this function?
Yep, that's the next one that we add. And I hope here you see the render function now. We don't want to render if the device creation was not working out. So the first thing we do, we clear the device, which means the 3D buffer, the back buffer, will be cleared in blue. And you can use any other color that you're happy with, including transparent or whatever you're up to. Then begin scene is telling the hardware basically, okay, now open up your reception for all the 3D commands that come down. On a device that doesn't have hardware acceleration, this command doesn't do anything actually. Then set stream source points the array where we put the vertices in to basically to the graphic hardware. So here's where your vertices are, upload them into your device. And then we call draw primitives, which tell the hardware again, okay, now you have the vertices, you have all the information you need, draw it. And with end scene, we basically close the hardware to the graphic card again.
Great.
So it's like open graphic card, stuff over to the graphic card, close graphic card. And then once everything is done, we tell the graphic card, okay, now show it. And then the graphic card copies from its back buffer over to the front buffer and shows it on the screen. So in a GAPI term, you would basically do all these things in a memory buffer, and then with the presence, you copy your bitlet, your memory into the GAPI buffer. that is how we would do it in the old days. So it's basically the same representation. Then you see the onPaint function. This is what we override with the render and invalidate. So every time the device wants to unpaint, we render, and then we invalidate again, so it will render again.
Right.
This is a very primitive way of doing
animation.
Mm-hmm. There are better ways now to do that, and there are great blogs out on the web that discuss especially these parts, how to tune that, how to optimize that, how to be very battery conscious. The best blogs are from Tom Miller, who is the lead architect on managed DirectX on the desktop. He has some great articles out there, especially on gaming loops. Then there's www.thecbuffer.com, also great source for tutorials and extra information about all this stuff.
Okay.
But I don't want to get too deep into that.
Are any of these blogs device specific, or is this, or doesn't it matter?
It doesn't really matter as long as you don't see any pokes or special interrupt calls into native DLLs. There's some recommendations on the main loop that say, well, you peek the message and you poke into the message and stuff like that. Mm-hmm. This is not something I would recommend. But there's another blog that's very good from Mark Prentice, who is the group manager for the managed DirectX stuff on the device. And he has a lot of tutorial and ideas and hints how to do these things too.
Right. Did you notice both of our spot watches beat at exactly the same time?
That's good. So it means the radio works. That's
right.
And on Paint background, that's another thing that we just override to make sure that Windows Mobile is not doing something that we don't want to have done.
Right. So that in effect gets rid of the flicker where the background might be drawn.
Exactly.
Right.
So if we start that thing now, we should see the rectangle. It should not rotate anything yet, because we don't call the setup matrices yet. So we basically, actually we need to call that. So let's see if I have this right. Setup matrices. So we do that before we actually call all the device code. We set up the matrices, rotate the triangle into a certain position, then render it. Okay. On the next loop, it sets up the matrices again by changing the angle. You see here's a tick counter that comes from the system, and it calculates the angle of the triangle.
Right.
So with every repaint, we should see the triangle move. Now, since we're running on the emulator, this will be an interesting effect. But if you run on the hardware, you see a smooth rotating triangle. So next thing we have to do is just build that thing, see if we didn't make any mistakes. No, looks good. And run it in the emulator. Now is a good time for some coffee or... Oh, there we go. So now you see the triangle has 3 different colors on the 3 endpoints. And what Direct3D is doing, it's calculating a radian between those 3 positions to show this nicely colored triangle. Okay, so you see there's not much you have to do to write code in Direct3D. Now, once you have that basic stuff going, you just add more vertices to it. There are mesh loaders, there are lights. There's a lot of stuff you can use from managed DirectX that you don't have to write yourself.
Right.
And as I showed you on the device, you can really have tons and tons of triangles with lightings and translation matrices running on a fairly let's say not too overpowered device. It's like, I think is a 400 megahertz, 400 or 600 megahertz ARM, and I still get like 1,000 triangles per second out of that thing, which is fairly decent for good 3D games, especially in the casual area, like puzzle games, action games in the form of simple graphics, or first-person shooters with lots of environments. That is where it gets tricky.
Right.
But everything else, there's no reason to really go down and develop all these things yourself.
So where would I make the decision about whether to use just raw GDI versus GAPI, Direct 3D, or something else?
Okay, so if you stay completely in the 2D world, you don't do any 3D calculations whatsoever, then GAPI is probably your best bet, because it gives you direct access to the hardware. If you build pure puzzle games like Solitaire, or actually the 2D version of Pocket Young only uses GDI, not even GAPI, because there's not much animation going on there whatsoever. It's really a very primitive puzzle game in 2D. Then you don't even have to go the GAPI route, because GAPI requires you to write a lot of things yourself.
Right.
You don't have any support whatsoever. You just have the bit buffer in the memory, and this means you have to write a lot of code, but you get performance out of it. So it's where you draw the line. As soon as you go into 3D space,
it's where you draw the line.
Yes, exactly. It's where you draw the line. In 3D space, it's really no reason not to use DirectX and manage DirectX to native my DirectX. The difference is so small that I only recommend managed code writing.
Okay.
Especially on devices that have the tool framework in ROM, which hopefully comes out very soon. As we mentioned before, you have to have Compact Frame 2.0 to run managed DirectX.
Yes.
And that is not in ROM in the current devices. So no matter what device you will buy on the market right now, you have to download the runtime and put it into RAM or in Flash.
Okay.
And that's about a 2 megabyte penalty for your device.
Right.
But on the other side, if you would write your game natively without DirectX, you probably end up with a 2 megabyte file size anyway. So, and then it's just one game or so. So if you have 4 of those games on it, you have 6 megabytes.
But what kind of time saving are you going to get between writing native code, 3D apps, versus managed code, 3D apps?
I would
So
say,
if I want to do everything by hand,
yeah. Well, by hand is a factor of 10x something, but native versus managed is about like a 40% gain in time. Because you don't have to do any ref counting. You don't have to do any strange vtable or whatever things that you have to do in COM.
Right.
You have to be more conscious in COM and native code than you do in managed code. Managed takes a lot of things away from you that you have to think about in native code. And this is time you actually save. And then I mentioned the matrix calculations are easier in managed code, I find. Probably it depends on your preference. If you are a C++ developer and you know that in and out, and you know you're a friend of ref counting, fine, knock yourself up. You probably then as fast as I'm in with managed code.
Right.
But if you're starting new with a device and you haven't done anything before that, look at managed code first and see how easy it is. All this was there are not many lines here. It's maybe pure code. It says 130 lines with some brackets and spaces in between. So I would say less than 100 lines of code for your first 3D app.
So
I'm pretty sure it's 3 times as much in native code.
So just taking the kind of the graphics and 3D aspect out of this, if you're going to be starting just a new enterprise application development on a Windows mobile device, PokerSeal smartphone, what would your choice of language or native versus managed be, and what would the reason be behind that?
For enterprise apps, there's a clear choice for managed code. There's really no need to go native for enterprise apps. Enterprise apps don't have any real-time requirements or performance requirements. Even if the managed app would be 20% slower, you would not really see that in an enterprise app. So and then you get all the stuff that modern technology has to offer in regards to web server success, code security. The runtime will be very small, easy to deploy. So for enterprise apps, I wouldn't even think about native code.
Plus you also get the speed of development versus
exactly, which is the essential in enterprise apps. You don't want to delay your release by 2 months or so just because you write ref counting stuff. So you want to ship it out as quickly as you can. And I wouldn't even bother with native code for enterprise apps anymore.
Right.
Yeah, and the 2.0 compact framework is so powerful now. It has really everything you need. there are gazillions of COM controls out there that help you with all sorts of things that you might need. And with the tool framework, you just interop into them very easily. So you don't have to thunk anymore, you don't have to p-invoke anymore, all that stuff that you had to do with the 1.0 framework, or use the OpenNetCF extensions. So with the tool compact framework, enterprise apps have a clear 100% go for managed code.
Okay.
Yeah.
Do you see the future of mobile and embedded application development at some point just being pure managed and native APIs going away?
I personally see that. I see that also on the desktop. So this is just a natural evolution that we move from assembler, we move to C++. From C++, the next step is into managed world, and whatever comes after that, maybe modeling or something like that. It's the evolution of technology that we're doing, and I clearly see that as the next big step, that we move away from native code.
Well, in each one of those steps, so you mentioned moving from assembler to C or C++, and then maybe the intermediate step between that and managed is the step between C, C++, and some kind of
Framework.
C++ framework,
Right,
whether it be
exactly.
OWL or MFC or something else.
ATL, right.
Yeah,
Exactly.
ATL, WTL, STL, all those kind of good things.
Yeah.
And then the step beyond that up into managed. But as soon as you move away from that assembler, C, C++ programming, all of a sudden as a developer you're moving into an environment where you have to put a lot of trust into the framework that
Right.
sits beneath your application.
Right.
So, yeah, on one hand you're getting rapid application development because you don't have to write all of that stuff that's handled by the framework. But the other side of the coin is that you
Very
get all
true.
that rapid application development, but at some level you need to trust the framework that lives underneath your application to
Right.
do what you want it to do.
And that's exactly the main reason why this will not happen overnight. It will take years until that is at a state where you don't think about these things anymore. The other danger that happens in this evolution is that we lose the connectivity to the hardware down. So when we were writing assembler code, we knew exactly how the hardware worked, how the timing was, and how which command did really what in the CPU. When
Yeah.
we moved to C++, we got one
Actually,
distraction layer over that.
I remember writing some communications code in assembler for a device before I started working at Microsoft, and counting the instruction time
Right.
for each instruction to see how tight the loop was,
Exactly.
and see whether there's anything that I could shave out.
Right.
Yeah.
I'm doing game development since '82, and in the dark ages of game development, we actually colored the raster lines of the screen to show how long our code would run. And so we had different color blocks on the background color of the screen showing how long which code part is taking. And if one was too large, well, we were optimizing to make it smaller. And we needed to be done with all the calculation in one frame, so we had 60 times the second to refresh. And if the screen was flickering totally, we knew we were over that one over 60th of time frame. And now with C++, we start not to care about that anymore. And with Manage, we don't care at all anymore. And developers that are coming out of school right now, they don't even know that there's assembler anymore.
Right.
There's a big danger that we lose really the touch to the hardware in a way that we don't know how the thing works anymore.
Right.
And
Well, perhaps it gets even more interesting than that. So at the highest level, you've got your application that you've written in C# or VB, and that's calling into the .NET Compact framework, and that loses your visibility to what's happening underneath.
Right.
Which, in many respects, is a good thing. It allows you to focus on your application UI and the special things about your application without having to care about the lower level portions of the framework and the operating system.
Right.
But even below the framework is the operating system itself, right?
Right.
So you have multiple layers of abstraction with your application living at the top of the thing.
Exactly.
So your level of trust not only trusts the framework, but also trusts the operating system
Right.
and the drivers and hardware abstraction layer
Exactly.
below that operating system.
Yeah, and if you look at the support chain for all that stuff, you might have very interesting support calls pointing you to different sites and moving back and forth, and especially with 3D stuff, you have to look at exactly everything, including the hardware of the graphic card now. So if you find a bug somewhere, you have trouble locating is it in the graphic hardware, is it in the operating system, is it in the PC hardware or the mobile hardware, is it the framework, or is it in your app? So the more layers you add, the more support calls you might have if something goes really wrong. But we're still in the very early stages of IT. We just moved out of the dark ages and into a little bit more comfortable ways, which is managed code. In the future, we might not even write code anymore. We just drag like little models around, and it does all the rest. And the more trust we have to add to it. And if something fails, well, we have to call one of those old beard guys and say, something's not working, and he digs into the assembler code and comes back 2 years later saying, oh yeah, I found the bug, it was a whatever. I don't know. So future will be very interesting in that space.
Mm-hmm.
But you know, we were in a world where everything has to go fast and quick, and if you can't build your products and your stuff in a very short time frame, somebody else will do.
Sure.
And that's what you're fighting against. You're not fighting against hardware. You're not fighting against bits and bytes anymore as you did in the 80s or something. You're fighting against competitors that have exactly the same material and tools that you have. And if they find a way to do it faster, you're out of the business.
Mm-hmm.
And that will be the main driver of this industry, which means you have to go managed, you have to go in fast production cycles, in high-speed productivity. And you cannot afford sitting there 2 weeks just tuning a little call into the assembler code. And then somebody ships a new CPU, and it's that same speed that you optimized 2 months for. So it's a very interesting world. And managed code is certainly helping you dramatically with all that productivity that you need.
Okay, great. Any final comments, thoughts before
Final
we
comments? No, I'm really happy with those devices, and I'm looking forward to release my new game by end of this year.
Right.
Yeah.
Great.
Again,
What kind of game is it?
I can't tell too much about it yet. It's I'm working with some publishers this time, so it's not a shareware game anymore. It's a full production game.
Wow.
Yeah.
Great.
As soon as I have something, I will of course tell you.
Okay. We'll get you back for that.
Yeah, well, I like that.
All right. Thanks.
Cool. You're welcome.